We need to solve for a moment at point C that will cause this system to remain in equilibrium due to the moment at point A called m of A. And we also need to find the reaction, the components of the reaction at the point C. So we can see that from the free body diagram that at the point B, there will be a force going in this direction that will form an angle about the horizon, which we'll call theta. And we'll call the force vector B, F of B. So to solve for this angle theta, we can write it as the tangent inverse of 8 divided by 8 divided by 6 plus 14. And this will give us an angle of 21.8 degrees. So we'll begin by solving for the moment at point C. So we can write out that the sum of moments about point A is equal to 0, which we can write as negative f of b times the sine of 21.8 times 8 minus f of b times the cosine of 21.8 times 6 minus the moment m of a is equal to 0. So we can now plug in the known values, which will give us negative f of b times 2.971 minus f of b times 5.571 minus 500 is equal to 0. And solving this equation for f of b, we get a force value of negative 58.535 pounds. And next we're going to find the y component of the force that's acted upon point A. So to get that force, which we'll call A of y, this is going to be equal to f of b times the sine of 21.8. And we can plug in f of b. So plug in f of b. And this will give us a force value, 21.73 pounds. And we can do the same thing for the x component. So to get a of x, we write this as f of b times the cosine of 21.8. And we plug in f of b. And this will give us an x component of negative 54.34 pounds. And to get the x component of the force at the point C, we know that the only force in the x direction is at point A. So by taking the summation of forces and setting it equal to 0, we know that the force in the x direction at point C is equal to the force in the x direction at point A in the opposite direction. So we say that A of x is equal to negative c of x, which will give us a value c of x that is equal to 54.34 pounds. So now you can write out again that the sum of the moments about point A is equal to 0, which we can write as negative m of A plus m of c minus c of x times 14 is equal to 0. And we can plug in the known terms and solve for m of c. So we have negative 500 plus m of c minus 54.34 times 14. And solving the equation for m of c, we will get a value of 1260.76 pounds inches. And this completes part A. Now for part B, we're going to find the reaction components at point C. And notice that we've already solved for the x component. So all that's left now to solve for is the y component. So to solve for the y component, we can say that c of y is equal to negative a of y, because just like a of x, the only other force that's acting in the y direction is at point A. So to keep this system in equilibrium, the y component of the force acting on point C has to be equal to the force at point A in the opposite direction. So using that terminology, we say that c of y is equal to 21.73 pounds. And from part A, we calculated that c of x is equal to 54.34 pounds. And this now completes part B.